So Mr. Kabil was worked in many geospatial data analysis, then geospatial data processing, visualizations, data analyst, and he worked as engineer, expert tutor at science, and we have GIS engineer at near intelligence, then senior GIS engineer. He can able to build and maintain geospatial data and interface to target for various spatial features, and also he can work with the geospatial data management, application enrichment, and building innovative tools and features. So today he is with us for providing how to work with geospatial data visualization, how we can work with spatial giant, and so on. So thank you, Kabil, for the valuable acceptance from proposal. So the session is yours, so you can take your session. Thank you.
Sure. Thank you, Mr. Naveen. Hello, team. So hope I'm audible. No issues from that end, right?
Yeah, audible.
Cool. Okay, thank you. So thanks for the brief, Mr. Naveen. So like Mr. Naveen Kumar was telling, I have been working specifically in the domain of geospatial science for the past 6 years and so. So I started, sorry for that, yeah. So I started as an analyst. When I say analyst, it was specific to GIS analyst. So I got to play around with all sorts of data that come in with geospatial data sets, starting from anything that is with respect to stores and locations on ground to satellite images or drone imagery, which basically helps us understand a little more on the ground truth. So that is a small brief that I can probably put from my end. So let's probably just get started. Let me share my screen. Please let me know once it is up. Okay. Hope you can see my screen.
Yeah, it is visible.
Okay, cool. Okay. So to probably just this screen is also visible, right?
We can able to see that guest e-lecture Ajanta
Yes,
PPT.
correct.
Yeah.
That's right. Okay, thank you. To get started, I've just put up a very plain PPT. So please don't look into it much because there is not much that you get to learn from this. It's just an agenda for me to go over things that I can share with you people. So let us probably start with understanding types of geospatial data sets. Why I'm starting with the type of geospatial data sets is, see, as a computer science engineer or somebody from tech, when it comes to geospatial data, there is not much difference when compared to any other kind of data set, except for this specifically stands to something spatial. When I say data sets, let's probably go look into your very basic types of data. An integer, a boolean, a float, it could be anything. So similarly, in any kind of database, it could be a SQL database or a NoSQL database. There are these. Sorry, there was some maintenance. Okay, cool. So yeah, so just like I was saying, when you look at these data sets, I'm sorry, there is somebody on unmute. Yes, thank you. Cool. Like I was reiterating on the types of data sets, just like how you have your integer, boolean, float, and so on, geospatial data is also something very similar when it comes to with respect to a specific database. When I say database, it could be anything from a SQL database to a NoSQL database. So starting from MongoDB or Postgres, could be anything. Over here, the data is stored in a specific type, which basically represents a geospatial value. This could be of multiple types again. Most of the databases support all three major types of geospatial data sets, which is a point, a line, and a polygon. So these are very basic representation of geometries when it comes to your mathematics as well, which again lays as a principle for all these GIS concepts. So again, coming into the geospatial data set a little more deeper, apart from these point, line, and polygons, there is also something else called as a raster data set. So these raster data sets consists of imagery. When I say imagery, these are just aggregation of pixelated values. And the other thing that I was just explaining, a point, a line, and a polygon are belonging to these vector data. So there are, I mean, when you look at data, there are vector data, there is raster data, and there is also something called attribute data. So attribute data is just a text or a metadata that is associated with a specific vector data or a raster data. So an attribute data cannot exist without a vector data or a raster data. So, like I said, attribute data just basically represents a metadata of either this or this. Like you're seeing in this picture here, over at the top, we can probably just put it as a vector data because over here, most of them are polygons. And you can probably take this for as an example for raster data because you can see pixelation over here. Pixelation is nothing but again gridding of specific landmass. Okay, so that's probably it with respect to that kind of data sets. Uh, uh, I hope I was clear until here because if unless you understand the kinds of data sets, there is nothing really that we can do with respect to geospatial analysis or anything that has to do with geospatial data. So, and once you understood what a vector data and a raster data is, probably you would be able to understand what to use on what kind of use cases or yeah, the problem solution that you're trying to figure out. So let me probably step away from this PPT. Let's probably dive into the data itself. So this is a tool software called QGIS. So this can be found online. You can download it directly, I guess. QGIS, yeah, it's an open source tool. You just head to its website. It basically asks you which kind of OS that you're running on. Based on that, you can download. It supports a wide variety of platforms, so that shouldn't be an issue. And by default, you get this panel. This is how the UI looks like the moment you open the app. Um, and once the application is open, just to understand or figure out what is going on really in this UI, you can probably just click on this XYZ tiles, and there is something called OpenStreetMap. So this is a basic map that is being provided by this specific platform toolset, which enables us uh, look into a map in a two-dimensional figure. So basic scroll to zoom in, zoom out, and all that. And the whatever you are seeing over here is again open source data set, something that is called OpenStreetMaps, which provides this data set. Um, they have it stored in multiple varieties. So I have downloaded one of their data sets. You can probably head to their website, something called GeoFabric, GeoFabrik. So over here, you get to download all kinds of data sets throughout the world. Uh, so over here, if you see, it's in the beginning split up by regions. Over in the right, you can see the highlighting as well, just to understand better. So I've already downloaded Indian regions data set in multiple varieties that they are provided in. So again, when it comes to GIS data sets, there is a specific method to store these data sets since they are not your daily conventional data types. Since they are since they are usually bulky, They are put in specific file formats, which are mostly compressed file formats. Over here, if you see, this is proto buffer file format that has been created by OSM themselves, OpenStreetMap themselves. And there is something called SHP, which is shapefile. Shapefile has been brought in by a company called ESRI, which is a widely known company for geospatial platform, and Zip, which is again zipped. And this is again OSM using their BZ2 zip file format. So similarly, there are a lot of file formats. Let me probably just quickly dive into this GDAL thing, which helps you understand the kind of file formats there are. So when it comes to raster, basically an image pixelation of data sets, there are a number of data sets. These data sets are derived from different sources of data capturing. So when I say sources of data capturing, it could be a satellite imagery, it could be a drone capture, it could be a basic camera that is custom built. So, and the way that they are stored and the way that they are formatted differs. So you can see there are a number of file formats which also has georeferencing inbuilt. When I say georeferencing in inbuilt, it basically knows the latitude longitude of each of the pixel, so that it knows where to go sit when you put it on a map. So that is a very basic explanation of that. And there is also vector drivers over here, which basically elaborates on the type of vector data sets that can be provided as well. You can see even a CSV over here, because even a CSV can hold a column called latitude and a column called longitude, which basically makes it a geospatial data file. And apart from that, there are a lot. One major thing that we would be coming across is something called a GeoJSON. I'm pretty sure you might have heard something called a JSON. So it's very similar to JSON. It's just that GeoJSON is put up in a specific structure. It's again a JSON internally. Let me probably just until here. I hope you guys have been able to hear me, and there haven't been any issues with respect to understanding what I'm trying to explain. You can probably stop me in between if you have any questions at all. I'd be free to take in any questions. Uh, are we clear over there? And yes, from anybody would help me. Go ahead. Am I audible?
Yes, sir. Clear, sir.
Yeah, thank you. Thank you, Daniel. Okay, cool. So going ahead, yeah, let me probably just go ahead by showing you specific data that comes in GeoJSON. There is this very basic UI tool, which is an online open source tool again, something called geojson.io. You are free to open this on any browser. It supports almost all browsers. Geojson.io is the web page. So if you open it, this is where it opens at. This basically explains us and makes us understand easily how geospatial data works. So over here, they've even given us tools like point, line, and polygon that we can plot up on the map. Okay, so over here, and when I was putting this, you could have seen that these data sets started appearing. So over here, let me probably just clear that up again, go from the beginning. So whenever I put a point over here, whatever you are seeing, this is a GeoJSON. It's a basic JSON structure that holds a key and a value. Over here, it starts with basically a type and basically explains what the type is. It's a feature collection, and when it's a collection, it's obviously a list or an array. Uh, so it basically says these are the features that I have. So these features could be n number of points or lines or polygons, or again, all these three can be multi-variety as well. So it can be a multi-point, multi-line, or a multi-polygon as well. So whatever you're seeing here, this is just a point. So over here, it could be a multi-point as well. It could be a multi-line as well. Similarly, let me just probably add one more JSON here. You can see the changes. You can see that these are moving over here. Let me just probably try to put it. You can see the changes, right? So these are all basically just geographical coordinates which are giving in, and the map basically renders it according to the pixelation of the screen. So it just directly decoordinates the 2D dimension of a map, that is map. When I say a map, something like this, the two-dimensional array, it just basically picks it up and maps it directly to the pixelation of your screen and moves it. It's I mean, very simply to be put, that is all it is doing over there. So similarly, you can add a line as well. Uh, it goes on. So when you can see the difference over here between a point and a line. Point is a basic array of longitude and a latitude. Line is basically an array of sets of longitude and a latitude. And when it comes to a polygon, this is also very simple. It's again basically a very simple line. It's just that it starts and ends with the same longitude and a latitude. So if you see here, it's 77, ends with 123, same thing over here, 9497, 9497. So this is all geospatial data set that majorly is used in today's world is made of. Anything that you see on a map, for example, your Google Maps, it could be your here maps, it could be any map that you are using on your day-to-day basis to navigate or anything. So everything that is made up of is with this kind of data sets. And when I say these kind of data sets, these are, like I was explaining, vector data sets. And to make it easy for your UI or your browser to render, they convert this data into raster data. So when it becomes a PNG or a pixelated data, it becomes easier to basically provide you the data, that is provide the browser the data to load and show it visually. So over here, whatever you are seeing, each of them are basically a PNG images. Uh, since you're all engineers, I can probably just make you better understand when I say raster and vector. So whatever you are seeing here, I hope the screen is visible. So whatever you are seeing here, these are just the encoded pixelated image, which are decoded by your UI and plotted over here. And if you go to Google Maps, you can probably see the PNG images itself directly. Let me just. So over here, you can see the PNG image that I'm showing you over here. Uh, so, so this is how a map is basically constructed and put up out to you. So that's pretty much it with respect to geospatial data and how the visualization goes. Coming back to uh, the major aspect of how to use the data and where to use the data, that is the analysis part. Uh, yeah, yeah. Okay. So coming back to let me just probably show you the data that I downloaded from this specific website, that is OSM, which I was showing. GeoFabric. Uh, so I've already downloaded a few data sets. So one of it is osm.pbf and the other one is a shapefile. Let me just probably open it directly over here. It's just a drag and drop. The UI can handle it. So you can see here that it's asking for the type of data that you want to load. So it basically says the file that you have provided has multiple kind of data sets, a line, a multi-line, a multi-polygon, and other kinds of iterations. So this basically says it's a collection of any of the three. And one more basic point. So let me just add everything. Okay. It's taking quite some time for it to render since the data is huge. You can see the loading bar here. It basically says the data is loading. Okay, let me do you one better. So you can see the time that it is taking to load over here, right? That's because the data is first of all compressed. And second of all, the UI also has to decode the data and then bring it up to the UI. So there is this huge lag, which is why depending upon the use of the data, the type of the data, that is the type of storage of the data differs. Like I was showing before, GeoJSON is easy to use when you are doing a lot of tabular manipulation, or let's say that you have your data put into a NoSQL database like Elasticsearch or MongoDB. Over there, it becomes very vital that the data is easily human readable. So over there, those kind of data sets are used, that is data types are used, GeoJSON and CSV and all that. But when it comes to tools like this and basic analysis and all that, we use file formats like GeoPackage, Shapefile, and all that. So these file formats have been specifically made so that it renders soon in a UI. So let me just, you have seen that the kind of time it takes to load just these many files. You can see the difference over here. I'll just sort it by. So over here, you can see for each file, there will be multiple different file types. So you can see here, there is .shp. For the same file, there will be another file with a different extension called PRJ. This PRJ basically says the kind of projection system that the data is. When I say projection system, uh, see, the base of that is Earth is three-dimensional. It's spherical or ovular, or however you put it, geoid, or however you put it. So you to basically put it on a map or on a screen that you can see and work on, it has to be made a two-dimensional figure, right? So when you are converting this three-dimensional figure into a two-dimensional figure, so you are basically projecting the three dimension to a two dimension. So there are n number of ways to project the specific three dimension to a two-dimensional figure. A very commonly used method is something called universal transverse method, UTM. So that basically splits and puts up your world into two-dimensional figure, and the units of measurement over there would be meters. And there are again n number of projections which go in a totally different way. That is your basic degrees, decimals, and seconds. So those projection systems, they are the ones that help you look at things in degree, minutes, and seconds. So whatever you say, 77.12 or anything that shows on a map when you're moving over a map, could be any map. Most maps show you it in degree, minutes, and seconds. So whatever you are seeing here is something called decimal degrees. Decimal degrees are just a conversion of degree, minutes, seconds into decimals, so that it's easier for mathematical operations. So again, coming back to this thing, the file formats. So depending upon the kind of data and your metadata, so your metadata is basically a DBF file. Similarly, there are a number of file formats that can be used to keep your metadata of your actual data under. So let me just open the shape files, which are the actual geometrical files. Let's see, I'm loading about 16 items over here. You can see the difference in speed of load. So that this basically shows the difference in the way that you store the data and the kind of data format that you use for your analysis or any kind of JS processing. Let me remove this one. Okay, so now coming to the core of geospatial data when it comes to your everyday analysis. Everyday analysis, when I say this, is mostly done on vector data, because doing your analysis on an image is basically image processing. That is an entirely different domain, which is not entirely needed when it comes to geospatial data processing, because what you're looking at is much more granular than a pixel. When I say much more granular, pixel, when I say pixel, these are the data sets that have been collected by your satellites or drone imagery and so on. the resolution of these pictures are mostly very less. For example, the satellite imagery that you usually see on your Google Maps, they are, I think here, okay, yeah, yes. So your basic satellite imageries, these are very, very highly resolutionized, because most of these data sets are open source. You can look at them where each pixel is of 30 meters by 30 meters or more. So that becomes way too high resolution to do your data processing, because most of your geospatial data processing would be for a much granular area or location. When I say this, for example, let's say that you want to figure out the direction to your nearest KFC. So this would definitely not be possible on your raster data set, because like I was explaining, that does not hold the necessary metadata with it. So we basically convert them into a vector data set. And this conversion of vector data set from raster data set could be of different types. When I say different types, it is mostly being done manually, but till date. When I say manually, people actually sit and draw polygons uh, over each of the building to basically say that this represents a building, not an actual polygon like this. It's basically a multi-polygon that is built like this. So there are at least, let's say, 500 companies that are in India, which has people over 100 who does just this, uh, which is why you are able to see your Google Maps like however you are seeing right now. Where you basically get to see buildings like this, right? And streets like this. So everything has been manually digitized, most of it, at least 90% of it. Not until recent days, we got image processing models like segment anything model, SAM, and neural networking and all that. This was very, very recent, let's say probably not more than 5 years. So until date, if you want precise data, people have been manually capturing that data sets. So that is how you actually get your vector data, on top of which you'll be doing your analysis. And these, so this is one means of obscuring these data sets. And there is one more kind of data set which comes with your technological devices. It could be your PC or laptop, your mobile device, anything. So when you have your mobile device, you have GPS associated with it, and any ad that you get on your phone mostly sends your location to the ad provider. So over there, your location is collected. That is one means of collection. And apart from that, when it comes to your laptop, PC, anything, cookies usually take in a location based on your IP, or sometimes if you have allowed the browser to use your latitude, longitude, that also goes in as well. So these are just small examples of how these vector data sets are generated. So majorly from raster data, that is your imageries, or data that is created from devices. So that mostly explains how things goes with the data sets. So coming to basic analysis of these kind of data sets, let's say, let me just so this tool basically provides you all kind of necessary tool sets that can be used to play around with the data and do whatever you want. So let me just pull one or two of them out. Yeah. Okay. So, okay, I think there are very less locations in these. Let me just pick up something that has more water. Definitely it has some road. Oh, sorry. Okay. So this works like your everyday. I guess you might have come across either CAD or any kind of creative tool sets like Photoshop and so on. So this is also a similar tool set which basically helps us play around with the data. So over here, if you see, there are a lot of roads. These are basically just roads that I've selected. I'll just remove the base map that we've been using so that it becomes clear on the data part. So over here, if you see, you can see this polygon, which basically represents water. So this could be a stream, a pond, a lake, could be anything. And these are all roadways. Over here, you can see small polygons also. These are mostly just small, excuse me, ponds and lakes. So let's see how many of these roadways go over these polygons of water. So how this would help, a small sample would be by explaining, see these polygons that have been generated, that too with respect to OpenStreetMaps, are quite old. So these water bodies that have been extracted from the satellite imageries go back at least 10 years. And these roadways are mostly updated by a lot of companies like let's say Meta, Microsoft, and so on, because there is this organization which basically helps putting data sets that private corporations are acquiring out to the open, basically to the open source data sets, thereby helping us get the data, and also they also get to use the data that is already there for their money making purposes. So this way both of us are beneficial. So this basically helps us understand a little in more depth about the data set. So what I'm trying to say here is the road network is a little more updated, and the water polygons are a little outdated. So when we basically try intersection of roads on top of the water, we should be able to get the water bodies that have depleted over time and on top of which roads have been constructed. This is just one small way to put up analysis, but again, this cannot be considered an 100% ground truth unless you have latest data to compare it with. So over there, it all becomes vital that you do all necessary steps to actually validate the data that you are working on top of. So yeah, okay, let me probably just go ahead with basic intersection. So over here in this tool, whatever you're seeing in the tool panel, these put up almost everything that you need. So vector, what we are trying to do is basic geoprocessing, which is an intersection. So I am trying to intersect what's this, roads free, okay, line on top of water. Okay, so let me just run it. So this basically runs it for me, and this could be using any kind of a backend API. So when I say a backend API, this could be using a basic C++ backend. It could also be using Python, and all this can be customized as well. And there is something else called a Saga GIS, which is also another tool which can be incorporated along with QGIS. So QGIS is a tool which basically helps you put together a lot of plugins internally. So when I say plugins, let this probably run for a while. This might take some time. One drawback with open source tools are, again, yeah, they take a lot of time. So that is one usual thing, but there are again a lot of programmatic tools which basically helps you go through things quite faster compared to these UI tools. When I say UI tools, why? Because the data is quite huge here, like you can see. This is for the entire central India. But when it comes to smaller data sets, UIs will be quite faster. That is these tool sets. But when it's large data, it is definitely advised to use programmatical tools. We'll shortly go there. But before that, let me just probably give a little more brief of how more you can look into the data over here. So pretty simple over here. You just right click on it. There are a lot of tools over here. So one is just looking into the properties of it, what the data holds. So this basically says what kind of data it is, the bounding box of the data, that is your top right latitude, longitude, and your left bottom latitude, longitude. And apart from that, you can also change the color of it and play around with the data sets, add a label to whatever you are seeing and all that. And apart from that, there is also attributes. Like I said, the third kind of data, which can only be associated with either a vector or a raster data set. So these data set basically provides you each field, matlab each feature. So let me just zoom into the feature that I selected. So it's just this polygon, whatever you're seeing over here. Okay. So n number of such polygons put together form one multi-polygon. So whatever you're seeing here, these are all just each of those feature representing a specific attribute. So this one, whatever we have selected is a wetland. It's called Gavain Tal. It's probably somewhere. It's probably just some small lake. Sagar Tal. These are all just lakes. Uh, so like I said, these attributes hold metadata of what that specific feature represents. So let us probably just play around with it. Let me just delete this field called area. And there is this delete option, and you can play around with this also. So let me just delete area. I'll just add it again. Let me put it in decimal number so that I want to calculate the area of each of these polygons. And over here, there is this summation, there is the small button over here. You can see what all can be done with this data sets. There is math, there is geometrical things that you can do. So there is area calculation also. You just do this dollar area, you basically get to see what it is. So I'm trying to calculate the area of each of these polygons. So I basically say in this area field, uh, provide me the area of each of these attributes. I just say update all. It might take a few seconds. There are a lot of data sets. Yeah. So you can see that each of these have this amount of area in meter square. Since over here you can see this is projected in meter system, which is why it's in meters. If we are looking at it in, like I said, in a projected system, which is degree decimals, it would be in degrees. So again, we will have to convert it to meters if you want to look at it in meters. So let me just probably sort it. Let's probably look at one of that. Okay, so this is a little weird. Okay, let's validate it. Okay, again, since OpenStreetMap is the same data that we are using, the same vector data that we are using to visualize, these are all probably just very small lakes that have been identified long back. So it's just probably not exactly a triangle, obviously, but just a small water body that was identified. So this basically says that it has an area of 2.3 meters square. Okay, so we can even validate that by using this tool called measure tool. It basically helps us measure anything on the map. So it's already in square meter. Let me just, you can use this tool to measure. Okay, I clicked on it twice. Okay, so if you see here, it says 16.5 meters square. So which basically says there is something definitely wrong with the data. So this is the kind of problem that we face usually with geospatial data sets that are open source. So what needs to happen is usually a lot of validation has to go through when you are using open source data sets, which is why there is something that has come up very recently called overture maps. So overture maps, this was very recent as well. They came out on 2023. So this is again built up by major companies like Meta, Microsoft, and so on. So what they've been doing is they've been cleaning up all this data. They have been putting a lot of efforts into uh, bringing it to a specific file format. They've been using Parquet because usually the data is huge. So you get to download the data from directly from AWS S3, Azure, and so on. So everything is provided here under their downloads. So you feel free to download these data sets and play around with them. And coming back to the intersection, it is still going on. Let us probably stop that. Pick up a very small data set. Okay, so let me just create a data here. Okay, so let me say the whole thing. Okay, there's a small lag. Please. Okay, it's taking some time. Okay, until that loads, probably I'll just go over the other parts of these tools. So like just like geojson.io, there is something called Kepler.gl. So this basically uses DeckGL as base. So DeckGL is another framework that can be used with React and JavaScript and TypeScript and so on. So this basically provides you a base to create your mapping tool or your UI with map with a little with considerably faster amount of loading with respect to the size of data when compared to other UI tools out there. Why I'm saying that is this geodestin.io, what you are seeing, this cannot handle high load of data. If you load a huge amount of data, the UI is probably doomed to crash because it is entirely running on your memory. So when it comes to Kepler.gl, since it's running on DeckGL, which is optimized to handle data's a large amount of data, it basically handles data better. I'll just probably just open a few files over here and we'll probably just go over it. So it's the same data that I created over here in geojson.io. I downloaded it. So here you can see that it has got plotted again, the same thing over here. Again, over here you get to play around with layers also, the color you want and all that. And stroke of the this thing and polygons, and you can basically do any kind of filtration on top of the data. So let's say over here there are no fields because I haven't given any attributes to it. But whenever you have an attribute, you get to select the attribute and do multiple filtrations on top of it. And also this basically enables a geocoder, which basically uh, helps you go to a specific address when you have a large amount of data. This is just a navigation like you have in your Google Maps, let's say Chennai. It's basic navigation over the map, brush coordinates, and you basically get to add more layers also and change the base map whatever you are using. So this basically provides a good platform to put in your data and share it with other people, because they have this direct share option where you can generate your own URL or export the data into an image or into a map. When I say map, it's basic HTML and or a JSON. So this is a very new tool that has been brought into to basically visualize data quickly over your browser rather than relying on softwares, which usually takes a lot of time to get it installed, set up, and sometimes even do basic processing. So that is that. Let me just open the data over here again. Okay, so one polygon over here. There is one point over here. So let me, what I'll do quickly is I'll just add this again, but not everything, just a point. So it basically becomes a different layer. Let me just remove these two. Okay, so let's just try our basic intersection on top of these layers, which should tell us if they are intersecting or not. Okay, so it already ran. You can see a file that has got generated over here, which basically says intersection. Let us open the attributes of it. It has, it just has one feature over here. Since there is no attributes, it does not have any attributes. If we just remove these both layers, you can see since only this point got intersected, only that has come out as a different file. And if you don't want to do it as a different file, there is again multiple tools over here where you can just select the intersection. I think it's somewhere over select by location. So you basically say compare these both and tell me which intersect. So it basically highlights the point that intersects on top of this polygon in yellow. So this is basic intersection, and there are a lot of other things that also you can do on top of these data sets. There is something called buffer. So buffer, what it does is it basically buffers your latitude longitude into a polygon based on the radius that you give it. So this is by default 10 degrees that is given. Let me just reduce it to 110. 10 is too much. This was also too much. So if you see here, it has just generated a buffer from the center to the degrees that we had given, which was around 1 degree. So that is pretty much it with respect to basic geoprocessing. And there are also a number of things that you can do with these tool sets. For example, let's say I want to generate a centroid for this buffer itself. Okay, I just select this buffer and run it. So you can see here, since there were three, there are three centroids generated as well. And the tool is quite efficient. Like you can get the feature count. There are 4 in total actually. So one over here, okay, which was created long back, and these 3. And apart from that, there are things like generating random lat logs inside a polygon, and basically adding. So whatever you see here, there is nothing over here, right, in the attributes. So we can also use this tool quickly to add geometries to that. So it basically creates one more layer which should have the geometries. Yeah, coordinate and y coordinate, basically latitude and longitude. So I hope that is a little clear. And apart from that, there is also something called merging. So when I say merging, this is basically to merge multiple layers, which is quite often used. Let's say that I want to merge these 2-point data sets. I select them, and I get to select the projection system that I want them to be saved into. It's just an offering by this tool. Once I run, I get the basic merge. So that is pretty much it with respect to these kind of data sets. And with respect to QGIS, and coming to other kind of tool sets that are very essential when it comes to uh, web maps, which is a very vital part of the geospatial data sets. There are a number of tool sets and the providers who provide your packages for a number of programming languages. The most used one would be definitely JavaScript and TypeScript. When I said JavaScript and TypeScript, you get almost all required packages for these languages. Also considering the most common frameworks like React and so on. So you basically get to play around with this. And apart from using any of these frameworks, you can still use your basic HTML and CSS to generate or open a map. Just for example, I put together this HTML. So what it basically does is it pulls up CSS from this source and basically says this is the JavaScript that I'm using, which is provided by Leaflet. Leaflet are again open source providers of base map and this specific package, which helps us play around with it. So this basically says put up a marker in this specific latitude and longitude. So, and this is what it does. Basically puts up a latitude and longitude and puts up an attribute with a pop-up of whatever I'm telling it to. So I basically say bind pop-up and open pop-up. I can add in any number of markers I want. For example, let me just add one for India. I'm just putting random Indian coordinates. So what it has done is it has put up that marker as well, whichever I said. Point in London, it says. Let me just say India. You can see the change over here also. Point in India. So there, it's this easy to basically create your own web map, and this is a very basic web map on top of which you can do all kind of manipulations, bring in the data you want, bring in an upload option to upload the data that you want, and so on. So this is one more tool, such tool called Open Layers, which is again widely used tool. But I would say this is a little outdated these days because there are a lot more tools that are coming which can basically use React and GL options to basically make your rendering faster on the screen. So there is one more tool that I wanted to show when it comes to data analysis. You can use your basic Jupyter notebook or any kind of notebook, your Colab and so on, to use these because these are basic Python packages. This has been built on top of Google Earth Engine APIs, and they basically help us put up these notebooks with all kind of data sets and do all kind of analysis on top of that. Whatever we were doing with QGIS can be done with this tool set as well, GMap. So it has very basic installation. You can go through it. I can probably you can probably note this down. It's geemap.org. So a basic installation, and after that, it's quite easy to use the utility. And apart from that, yeah, that is pretty much it that I wanted to share. Any questions from the team, or any questions that you have with respect to the data, or anything that you wanted to know that I haven't covered? I'm free to take questions. Okay, any questions, guys? Or else that is pretty much it from my side. I think I've covered what I wanted to cover. Any other questions with respect to geospatial visualization analysis or anything? I'll be free to answer. Okay then, that's pretty much it. Thank you. Thank you for listening. Hope it wasn't boring.
Kapil sir, are you there?
Yes, I'm here now. Hello.
Is they have any doubts?
Yeah.
Students, you have any doubts? So thank you for being patient for the past 1 hour. I will share the recording to your Google Classroom as well as the YouTube channel. Please go through, make a use of it. And if you need to work with more geospatial data analysis and visualization, I will send this as the email ID. Please contact with him, and also will share Sar's LinkedIn profile also. Make a use of it and go further discussions in geospatial data visualizations. And thank you, Kapil sir. Thanks for the opportunity for us for being a resource person. We will invite you once to our campus. If possible, you will be feel free to come and visit our campus. And thank you so much, sir. Thanks for the session. Thank you.
Thank you, Mr. Arvind. That was good.
Yeah, thank you, sir.
Thank you. Have a good day, guys. Bye-bye.